This is an overview of a product we're trying to design. This is a competitor product and we think we can improve it better. What we're needing is 3D rendering and CAD drawings showing the makeup of the product. The design can be all metric. So for example, the center tube, as we'll show here, and other items can be done in metric units. So let's start here. This is a video showing how the product is assembled. So what we see here is we see what is called topper, and through the center we have a pole that will extend. The pole will go up and down through this. So this will be actually assembled on the bottom, and the topper will be pulled up through the top. And this little piece right here is a knockout that will be knocked out. And this is, by the way, made out of laser cut steel. These J hooks over here then go around the outside, and the strips are clipped onto it. Now, our design is a bit more sophisticated than this, and even that they can be laser cut, we believe that we can do this a little more efficiently. These holes here are used to allow cables to pass through to the top. This product has a few defects in its design, but it's an overall relatively good design. Okay, so what I'm going to do is go ahead and play it. So the first thing the customer has to do here is put all these hooks into this unit, which is something we don't want. What we want to do is we want to have them mount these mounting strips directly into the unit. So I'm going to pause this and go over to our product. So here's our product, and it comes in a variety of different sizes here. You can see a large one and a small one and a very, very large one. So what we have here is, let me get to a picture where it's closer. We have these little slots, and you'll see that they're actually in and out, in and out. So there's actually two slots. So this would be number 1, number 2, number 3, number 4, number 5, number 6. And so they're staggered. And here you can see the strip, how that works. So the strip is actually slid up through there, and then there's a zip tie put into the strip. So let's show you the strip. The strip is this product right here. It's a piece of plastic, very thin, and it is then punched with these holes. And so these little tiny holes at the sides, the 3 holes on each side, we put zip ties in these, and it creates a stop. So these strips actually get stopped in the unit, and there's a video that explains how that works. And what this does is you've got one behind, one in front, one behind, one in front. And we do machine these out of plastic as shown here. But we believe that the same design can occur in laser cut steel since it's so precise. So instead of needing something that's 3/4 inches thick, we can go to something that's steel and much smaller. So let's just back up here. So these are all the different units. So there's an example of it mounted, and this is where it has had a pole going through, a center pole going through the center that's round. Here's one where they have it mounted, and it's got a large clamp on the bottom. Now, the problem with this is this does not allow for jacking up, and this is a major advantage of this other design. So I should probably state that this purpose of this entire product is to make something that looks similar to this. It's a tree. And let's just get it here, pictures. The tree has got a pole in the center, and there are lights that come down the side, and each of these strips, these little black strips, hold lights in them. And then ideally, this is a very short one, but then the pole would be jacked up, and you're going to see that in the video we continue on. So first thing is that the outside would be the stripped base design, not based upon the J hooks here. Okay, so let me go ahead and continue playing. So the customer has to, of course, hook all these together. It's a long and laborious thing. And as you can see, the hooks, even though they're close together, means that the strips aren't quite as close as they could be. Now, I'm open to any other design that may be even smarter than this or the one that we've come up with. So anytime you have any idea of a better design, we're all for that. So this piece is an eyelet, and that's going to clamp in one side. And what that's going to do is that is going to allow a cable to attach to it. So there's a winch. This is just a standard off-the-shelf winch used for boats and other projects, and it's got a hand crank on it. You can see it's got a hook already on the other side. And all this does is allow you, and you can just barely see it at the bottom here, the wire is going to go over this pulley, and it's going to crank up the center piece. All right, so this is off-the-shelf component. This ultimately would just be bought from a Chinese supplier. And the only difference here is their product requires you to drill a hole and put this product into the pole. And we believe that it should actually have U-clamps with bolts so it can actually strap along the side of the pole instead of bolting to the pole. All right, so now what he's doing here is we have the top. This is going to go at the very top of the pole. And that pole will have this wire go over the top and then connect to that center round piece, which is shown over here on the left. And it'll jack the entire thing up. And this is just a standard bearing-based wheel. Okay, so now what's happening is he's drilling holes in the pole. Now these poles right here, these are sourced by the customer locally, and we would send these. Actually, we would actually manufacture these for the customer. So this vendor makes you buy a pole out on the market, and customers often can't find those items. And so I'll talk about the specifics of the pole in just a moment. But its main characteristic is, one, that it's square so that things can't turn. And second is that it's square, and you can then bolt this winch on. So now he again has drilled a hole through this pipe, and based on our design, we don't think that that's a good idea. That requires customers to have special tools and drills, and we think just taking this winch, having a clamp that clamps around it, and then clamps the whole thing like a boat clamp normally would. So you can see this is an entire separate step. Okay, so what we're seeing here is there's a ring. This is a 10-foot hoop. Now we would probably sell these in differing amounts. These are made and they simply just have curves in them. They're cut and then they have tabs welded so that on the inside you can use a bolt to attach them. And they're just attached together in sections, as you can see here. And he's just attaching each of these sections. And he's forming an entire ring that the strips of lights will attach to. Okay, so now he's got the topper in place, and he's going to put that onto the pole. So here's our pole right here, and this is going to slide through this. And you can see it's not attached in any way. There is no bolts or anything else holding it in place. It's just jacked right up. Okay, and so then he has this top piece that he's got in his hand, and he's going to slide that on there. And that is the cap, and that actually caps it, and then this allows the wire to go cap attached to this bolt, go over the top, then go through this slot, and then you can see over here is the winch. Okay, so he has attached the winch. So now you can see the winch cord attached through here going down to the winch. Now, just a few issues here. One is this doesn't allow you to extend on further. Most people will put a star on top of this, and this has no provisions for the star. So the first correction we need is this wheel should be put inside the pipe. So there should be a coupler here, but what it should have is the pipe should extend through that and or allow an extension onto this top piece so that the customer can then connect something on top of the tree that extends on further, most namely a star. Okay, and the other problem is that there's no guide to keep this wire. So if in any case you lose tension on this wire can pop off and the whole thing can slide down the tree. So it's got a safety issue by the fact that it's not directly attached onto this. Okay, now what we see here is there's a four-way connection. So there's four ways horizontally and one vertically. The design you're going to see is not that good from a structural standpoint. Probably, ideally, a structural analysis would be done on loading. But what he's done is he's basically taken these poles, the same kind of poles we have here, and he stuck them out here and they've bolted in, and we'll see that. So all he's going to do is lift it at an angle, and you see that he's going to walk it up like a tent pole here, and it's going to crank up, and then this guy is going to push this to ground. So these will all be laying on the ground. Okay, so what we have here, we have this four-way connector that has a vertical piece going up. You can see the winch bolted on here, and these are just legs that provide stability. Several problems here. One is, of course, the structural strength of this connection looks very, very iffy. Not only should these things be longer, but there probably should be gussets that go in between here. Then he has bolts that simply just crank down onto the pipe to keep it from coming out. So the first thing is to improve this overall design. Otherwise, it's pretty good. It would use the exact same pole as the vertical piece so that all of these poles could be used, and you could use these poles either in the vertical piece or on the horizontal pieces. And we'll talk about the poles here in a second because they need to be sectional so that they can be easily shipped to the customer when even they're longer in length. Okay, so he simply just got a bolt welded into this frame. You can see that these are about probably almost quarter-inch steel tubing. Again, I still don't feel comfortable with the fact that even though this is all welded, that this is a strong enough connection. Loading analysis would probably tell us whether that is, but probably there needs to be some gusseting and these need to be extended outward. Just seems a little dicey. He's going to bolt those down, bolt the top one down. This holds all the pieces in place. Okay, now they're just taking their ring, putting their ring out over the top of the tree so that it's in the center. So they're undoing this to move it. They got to get it around that pole. So they drag it out there, and they haven't tightened all of those onto there yet. So they're just putting them out there, laying it down. Okay, what's happening here is they're taking each of these plastic strips and they're attaching them as they go around the tree to create an entire thing. They've got it cranked up just a little bit above the crank here, you can see. It is just right here at the bottom, and they're putting them all on. And we can see that this design, you can see a bunch of holes here. And this is because the design is not optimal because the lights don't go right up to the edge of the topper. So in the design that we've come up with, that allows for that to happen. And as you can see here, whoops, the pixels, the lights go right up to the top. He's got large gaps where there's no lights because of the way they clamp them in there. All right, so we attach that. He's putting them all in place. Now, I should mention this is 64 individual connections. So in an ideal world, what we would have is the product would be designed so it could handle multiple different sizes within range. And if you look at our current product range, you'll see that that exists. So for example, if we look at this product, it actually has two rings. One ring on the outside for one count, which is 64 strips, just like what you see in the video. And then on the inside string, it has 32 strings on the inside. And so the laser cutting would probably allow for that, so that if you wanted to make a big one, you could use the outside ring. And if there weren't too much material chopped out, you could then use the inside ring for more flexibility. So we would only need one SKU to handle multiple different size trees. And I can provide the exact numbers. Those are listed in examples here on our website. And we have the different specifications and how much spacing and how many degrees of coverage and all that. Okay, so he starts pulling it up the tree, just cranking that up. Now, what's happening here is it says crank it up, bungee on each string. So a bungee cord, a little tiny bungee cord, goes at the bottom and it attaches to the ring. And that provides enough tension to hold it in place, but not overstretch it. So what's happening here is you're basically creating tension when it reaches the top, and these strips are cut to a specific length, and then they are bungeed at the bottom of the tree. And so we'll take a look at what it looks like when it's done. And so you can see that there is a gap here, which is what we're not looking for. We're trying to get that tighter, and you can see how the pixels are not real super tight here. They're tight, but they're not super tight. We want them really tight, and by moving those strips right up to the top, creating as little gap as possible there. Okay, you can see that there, the gap. And it's really hard to see, but there's little tiny short bungee cords around the outside here. And those just hold it down. Now, what is missing here and missing in their design is there is no method here to attach these to the pole. Also, ideally, when they would be manufactured, we would have the company either laser etch or mark somehow different spacings in here. We would be able to indicate common spacings, and we'd be able to provide that to you. Okay, so that's basically the video on what we're looking to have modeled. Now, let me back up here because one of the things we were talking about is the pole. And the pole here, we need to be able to ship this. And this length has to be under 7 feet. So 7 feet or less is how far this can be due to shipping restrictions. So, as such, these poles have to be able to be connected together. And because you need to crank something up the center of these, move them up, that means that there needs to be an inside joint, not on the outside, but on the inside. A joint has to be made between these connections. So there would need to be a piece of pipe. They would probably drill holes and then plug weld the joint into there. Or in a certain case, you might be able to swedge or collapse. That would actually be cheaper. Collapse that inside piece into there to allow it to slide into that. And so what we would have is multiple sections of these pipes. That pipe could then either be used on the base, or you could put multiple sections going up. And we would probably offer those in differing versions, 7 feet, 5 feet, 3 feet, whatever it might be. That concludes this video.